Hi dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 477. In this lecture, we will try to understand Medoids. So, one other basic problem with classical k-means or k-means plus plus is that your centroid. At the end of it, you get centroid C1, C2, so on, Ck. Originally, you get a dataset capital D, which is x1, x2, so on, xn. At the end of the day, when you want to interpret your centroids, these centroids C1, C2, so on, Ck may not be interpretable. Let me explain this with an example. Let's assume I have taken Amazon Fine Food reviews. Just try to recall, each xi represents a review and it is represented using bag of words. I request all of you just try to go through my lectures on bag of words before understanding this. Your C1, C2, C3, so on, Ck, all these are computed using the geometric center point. I can say mean of points, isn't it? C1, C2, Ck are mean points, which means let's take any cluster centroid. Let's take C1 itself. Your C1, if you look at C1 from bag of words perspective, I have some words with 0.2, some words with which are 0, some words which are 1.2, some words which are 2.4, lots of words which are just zeros, isn't it? In bag of words representation, in BOW representation, each of these features represented a word W1, W2, W3, W4, so on, isn't it? Now, if you give this centroid C1 to me, how do I make sense of the centroid? I can't read this review at the end of the clustering. You might say this is the first centroid C1, this is the first centroid C1, but I can't read and interpret this centroid. Instead of giving me a centroid, if you give me one of the points, idea here is this: instead of giving me CJs computed using means, that's what we do in k-means, isn't it? If you give me some point, x10 belongs to D, which is part of data set, isn't it? x10 belongs to D, which is the part of data set as first centroid. So in the case of Amazon Fine Food reviews, your actual data point is review, because I can read this review and understand whether it is positive review or negative review. Let's talk about polarity here using one of the data points as cluster centroids, isn't it? Returning one of the data point as a cluster centroid instead of something that we computed using means. Since I can read and understand review x10, that review x10, that is more interpretable, isn't it? X10 is more interpretable. In the same example of Amazon Fine Food reviews, if you give me a vector like this, I can't make sense out of it. Instead of giving centroid like this, if you give me x10 as first centroid, I can see what is the review text. I can read it, which makes the whole thing much more interpretable. So that is one of the drawbacks or one of the problem of k-means or centroids may be non-interpretable. Centroids may be. Now I will repeat, one of the problem of k-means or our centroids may be non-interpretable, may not be interpretable. So what if so the big idea here is what if each centroid is a data point in D? Each CI is an xj. Each centroid is a data point. What is this xj? Xj belongs to capital D, isn't it? Yes. Then your k means what if, I will repeat, what if each centroid is a data point in D? Then your k means becomes k medoids. Then your k means referred to as k medoids, because you no more have mean point as a centroid, you have the actual data point as your centroid. Such a system is called k medoids. It's a very popular algorithm, especially as it is a very popular algorithm, especially when you want to interpret your centroids. Whenever you want to read your centroids and make sense, whenever you want to interpret your centroid, k medoids is very popular algorithm. Let's understand k medoids algorithm. So one of the popular algorithm for k medoids is called partitioning around medoids, PAM. This is the algorithm, just like Lloyd's algorithm for k means. PAM is an algorithm. PAM is an algorithm for k medoids. It's a very similar to k means with some differences. I will continue my discussion on k medoids in my next lecture also, that is lecture number 478. Thank you very much.